Hi everybody, welcome to a video called Loops Beyond Counting. In this video what I want to do is just talk a tiny bit more about loops because what we've seen with loops so far, and that includes while loops and for loops, is that we're using them really just to count, right? To do something a set number of times. So we might be drawing a caterpillar, for example, and we know that we need to draw each segment of the caterpillar, and there's like 10 segments, so we count from 0 up to 10, and each time we count 0 we draw a segment, 1 we draw a segment, 2 we draw a segment, etc. until we've drawn all of the segments. And that is by far the most common use of loops, but it's not the only use of loops, and so I want to just quickly look at another way that you can use while loops in particular, just so that you know about it. You're still going to end up using loops almost always for counting, but it is worthwhile seeing what it looks like to use a loop for something else. All right, so let's begin with this process by writing a small program over here. I'm still in my little sandbox kind of experiment project, and so we've got a blank canvas literally here and a blank program. So I want to start off just by setting up a little task, which is that I want to draw a circle in a random position on the screen. Because I'm going to draw it in a random position and I can't use the random function up here at the top of the program because P5 isn't loaded when this code runs, when this variable is created, I'm going to make x and y undefined. So I know that I'm going to define them in a second. I have to give them values here when I make my object. I can't put nothing. So I write undefined, and that signals that I know that there's nothing in them to begin with. Then I'll make my canvas, just the usual business going on here, and then I will position my circle in a random place. So I'm going to say circle.x is a random number between 0 and the width of my canvas, and circle.y is a random number between 0 and the height of my canvas. So that gives it its random position. And then, of course, we have to actually draw it, so we need a background. I'm going to fill my circle with white. I'm going to have no stroke around my circle. I'm doing this because I'm going to use it in a moment, because I'm going to draw something else. But just for now, we then draw our circle, circle.size, right? Okay, so that's a small program, and what it does is, when my program loads, so in setup, the first thing that happens in my program after creating the canvas is I choose a random x position and a random y position for my circle, and then thereafter in the draw loop I just draw the circle at that position, right? So if we go and look at that in the browser, there's the circle. That's a random position, right? It's not necessarily obvious from a single example, but if we reload the page, now it's up there, now it's down there, now it's over there, etc. So random location. Nothing too controversial right now. And we don't need a while loop to do this, right? There's nothing we can solve with a while loop with this basic idea. However, let's consider a very real potential situation that there's going to be a place on the canvas that I don't want my circle to end up on when I position it, okay? I'm going to call this the danger zone. Just because that's a cool, exciting name. Look, I forgot a semicolon there. There should be a semicolon there. So I'm going to define the danger zone. The danger zone is just going to be another circle that defines a specific area. It's x. I mean, I could make this undefined, but I'm just going to set it to 250, which is the center of the canvas, and its size I'm going to make 150. So that's how big the danger zone is. I remembered my semicolon this time. And again, I'm just going to position my circle randomly to begin with so that we can kind of see the problem. And now I'm going to need to draw my danger zone as well. So actually let me add a little comment in here. Danger zone, it's going to have no fill, so it's sort of easier to visualize as a zone instead of a completely sort of solid object, so to speak. Clearly, the color of the circle's outline should be red because it's dangerous, and then I just draw it in the usual way. Danger zone.x, danger zone.y, and danger zone.size. Okay, so now we have a slightly, I don't know, it's not a more complicated program, but we're drawing something else, and we have a more complicated idea, right? Which is that now there's this danger zone in the center of the canvas, 150 pixels wide. It's red, and we don't want our circle in there. And we succeeded this time, right? So this is almost like, you could almost imagine this as a game we can play. It's like any form of gambling. We could reload the page, and circle's not in the danger zone, so I don't know, we win 1,000 points. Who knows? This is like a very primitive form of gambling. It's not totally different to a slot machine, though. And I reload, and I reload, and I reload, and I reload. And there you go. Now, the circle has ended up overlapping the danger zone, which is bad, I guess, in my program. So I could turn this into a game and say that it's something that the user tries to avoid themselves and sort of put the burden on the user. But what if in my program I wanted to guarantee that the circle never ends up in this danger zone? Right now the program does not do that. The circle may well end up in the danger zone. I can't control it right now. This is a very specific example, but you could imagine, for example, wanting to randomly position something and not wanting it to end up on top of your user interface, or not wanting two things to end up on top of each other at the beginning of your program, for example. This is happening in this instance because we're using random numbers. As you move on in programming, you may well find other scenarios where this comes up as well. For now, I just want to look at how we might solve a problem like this. So we've got a danger zone, and we've got our circle being randomly positioned. I don't want the circle to touch the danger zone. Right now, the program does not work for doing that. Now, if you're thinking about this, your initial response could easily be that we'll use an if statement, because then we can check if the circle is in the danger zone and respond, right? So how do we check if the circle is in the danger zone? Well, we need to wait until we've positioned it, which is line 16 and 17 here. And the easy way that we can check whether two circles overlap is by calculating what the distance between their centers is. So this is just a standard thing that we end up doing. So I'm going to use a variable called d to temporarily hold the distance between the two circles. So d is going to be assigned the distance, dist, between circle.x and circle.y, which is the location of my circle, and danger zone.x and danger zone.y, the center of the danger zone. So then I'll know how many pixels apart they are. Then, once I know how many pixels apart they are, I can ask the question, right? How are they overlapping? And the way that we do this is we say if the distance is less than my circle's size over 2, which is its radius, plus my danger zone size over 2, which is its radius. We add those together because if the distance is less than those two radii added together, we know that the circles necessarily overlap. It's just geometry at that point. So this allows us to detect the situation that we don't want to happen, right? That the circles overlap. And if it happens, we could at least take a simple action, which is if they overlap, let's put it somewhere else because it overlapped with the danger zone and we didn't want that to happen, right? And this is a partial solution to this problem, right? We check if they overlap, and if they overlap, we just put the circle somewhere else by giving it a new random position. And if we go and look at our program, the circle does not overlap. It's really, it's writing the line there. It's pretty close, but it doesn't. And if I reload, it doesn't, and it doesn't, and it doesn't. Oh, but it does. Now, why did that happen, right? Because we were repositioning it to avoid this situation. And you probably already know the answer to this, which is that what has happened here is that the first time I gave it a random position here, we know that it must have overlapped the danger zone, right? That must be the case because we see that I mean, for one thing, we can see it's overlapping it now. But then we did do this little thing here, which was to try and not have it overlap the danger zone by checking. So the first time it overlapped, we would have checked and noticed it and put it somewhere else. So that was meant to be our solution. But the problem is that the somewhere else, the second time we positioned it, was also in the danger zone. It was this position here. And because our if is finished now, there's nothing we can do about this. The program is just going to run from here, and the circle is still in the danger zone. So because it got positioned in the danger zone both initially and then when we repositioned it, there's nothing more that this program can do. So an if statement is not the solution here. What we really need to do is we need to use a loop, right? We need to keep checking, is it in the danger zone until we get it out, okay? And that is what a while loop can do. You know that, right? A while loop does something until some condition becomes false. So let's think about what we need in a while loop that would handle this situation here. So we know that when our program begins, we've just positioned our white circle in a random location. So something like that, right? We've put it somewhere random, and the other thing that we know is we don't want it to be in the danger zone. Okay, so that's the starting context that we would have before our loop begins. That's the situation. Now, we know that a while loop has a condition, and we know that for as long as that condition is true, the while loop is going to take action. So our while loop needs to check if the circle is inside the danger zone, because if it is, we need to reposition it, and we need to keep trying to reposition it until it's not. So that's when the condition would become false. So what action does our while loop take? Well, it repositions the circle, right? So the while loop is going to say, is the circle in the danger zone? If it is, we reposition it, and then we check again. That's what a while loop does, right? Is it in the danger zone? If it's still in the danger zone, we reposition it, and then we check again. And we keep checking until we've finally managed to position the circle outside the danger zone. So let's go actually write that code. So what we need is actually very, very similar to what we already have. The big problem with the if statement, right, is that it only checks once. And what we want is a while loop that checks over and over again. And a while loop is a lot like an if statement. So in fact, in this instance, we can just change this if to a while, because now it's asking the right question. While the distance between the circle and the danger zone is less than their radiuses, which is, so this is saying while the circle overlaps the danger zone, which is the bad thing that we don't want to happen, reposition it. So that's good, but now the issue is after we've repositioned it, the distance will have changed, right? So we actually need to recalculate the distance between the circle and the danger zone after we reposition it, because we know that the while loop is going to check this again. And once we've moved the circle, this d, this variable d, which is meant to be the distance between them, is now out of date. So it needs to be updated after we've moved it. So we can use the same thing. Recalculate the distance by saying the distance is circle x and circle y, which have changed on the previous two lines, and the danger zone x and danger zone y, which have not changed. The danger zone doesn't move. But now we're good, right? So we say, first time through the while loop, is the circle overlapping the danger zone? If it's not, this while loop does not happen, and we're fine, because that was the situation that we wanted. If the first time through it is overlapping, we reposition the circle, lines 21 and 22, recalculate the distance, because we need to check that, and then we go back to the top of the while loop and we check again. Well, is it overlapping now? I moved it. Is it overlapping now? If it is, then we just keep doing the same thing until it's not. We know that eventually, by generating random numbers, random positions, the circle is going to eventually not overlap the danger zone. When that happens, this is going to be false. It's not going to overlap the danger zone. Our while loop can finish, and our program begins with the circle not in the danger zone. So the beauty here of a while loop is not that it's counting to some specific number, but rather that it continues to do an action that's meant to eventually correct a situation for us. It's going to do something until we have the situation that we want. And this is the other use of a while loop that I wanted us to know about. Okay? So it's not about counting a set number of times. It's about doing something until we reach our goal. So let's go and look at that quickly. It's going to do what we want. I mean, it's not really possible to watch it not work, because now it works. So not in the danger zone, 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 etc. The circle will never be in the danger zone, because anytime it is positioned and set up in the danger zone, that while loop is going to take care of continually repositioning it until it is not. And that is a beautiful use of a while loop. Okay? That's it. That's what I wanted to say, just so that we can see that loops are not just about counting, even if that's what we normally use them for, but rather that a while loop in particular can kind of relentlessly keep trying something until it achieves the goal that we've set, until the condition that we were checking for becomes false, meaning that the situation is what we wanted. In this case, that the circle's not in the danger zone. That's all that I have to say about this. It's just important to know about. It doesn't mean that you have to use it every day of your life. It is rather just, it's an important and useful use of loops that may come up at some point. So hope you enjoyed that, or at least were listening and can remember it some other time when it comes up in your real life. Thanks, and see you next time.